All right, ladies and gentlemen. So let's begin. Today we get into trigonometry with a full circle here. Okay, so let's get into this here. Converting degrees to radians and vice versa. So today we're going to keep it simple. We're just going to be using degrees and radians and converting back and forth. Okay, so let's begin with what is a degree? We know that a full circle is 360 degrees and that we measure angles, right, with this protractor here, that this tool that I'm sure you've all used before, right? And this goes from 0 to 90 and then it ends at 180, right? Now remember, this only measures up to 180 degrees, but we know that if we were to continue traveling here all the way around the circle, we would have another 180 degrees, and that would be 180 plus 180, which makes 360 degrees. So we know that a full revolution or a full turn is 360 degrees around the circle. Okay, we know that a half revolution, if I were to just draw the diameter all the way across here, halfway around the circle is 180 degrees, and then halfway across half of a circle, right, would be 90 degrees, and that's why we have the 90 right up here on the protractor. Okay, so notice if we were to count by 90s, 90 plus 90 is 180, plus another 90 would put us at 270 right here, and then the third 90 would make it 360 degrees. Next, well, what is a radian? Okay, so a radian is another measuring unit for measuring angles. Just like degrees was one measuring unit, well, a radian is another type of measuring unit we use for measuring angles. But this time, we're not using degrees, we're using a radius. So it's using the length of its own radius. So let me explain what that means. Let's say, for instance, we take this radius from this circle. Let's say we have an uncut pizza, okay, or an uncut pie, and then you decide, I'm going to go ahead and cut a slice the length of its radius. So you measure from the center of the circle or the center of the pizza to the edge, right? And then you say, okay, well, I'm going to go ahead and estimate that's about that much, right? So the length of this radius, if I were to measure it along the edge of the crust here of this pizza, right? And then I go ahead and connect it right to the center again, and that's how big my slice is going to be. That would be considered 1 radian, okay? Or we could just call it 1 rad. It's an angle. Okay, it's still an angle, and that's a little symbol we use for angle. So this would basically be the length of a radius. That would be another radius, right, from the center of the circle to the crust. And then the crust here is actually the same length from here to here also. In other words, if I were to take a tape measure and I measure this, and I would take the same tape measure, right, and just curve it around the arc of the crust, and it would measure the same amount. So all the way around, these all measure the same. Okay, so that's why we call it a radian, because it's basically using its own radius to measure it. Okay, so now imagine how many of these big slices would fit in this whole pizza. Like, how many of these slices can I actually cut all the way around so that I have all equal slices, right? And so, in other words, how many radiuses fit around this circle? And actually, we have a formula for that you've used in the past. C equals 2 pi r. Okay, now remember, C stands for circumference, which is another word for perimeter, which means the distance around. So the circumference around the circle, or the distance around the circle, is equal to 2 pi radiuses. Okay, and so in other words, whatever the length of the radius is, just multiply that by 2 pi, and then you have the distance around the circle. Okay, so in other words, all the way around the circle is equal to 2 pi radians. So the circumference is equal to 2 pi radians. Okay, in other words, 2 pi, which is 2 times 3.14, 2 times 3.14 is 6.28. Okay, so in other words, the circumference of any circle is always going to be 6.28 radians. Okay, what does that mean? It means that it doesn't matter how big or how small my circle is. If I were to take the length of its own radius and wrap it around the circle, I could only wrap it 6.28 times. Okay, It doesn't matter the size of the circle. This will always be the case. Okay? And so, let's go ahead and use that information now to develop an equation here. Notice here, it says here, since 360 degrees is a measure around the circle in degrees, and also 2 pi radians around the circle in radians, in other words, the distance around the circle is also in radians, 2 pi radians, then we can say that 360 degrees is equal to 2 pi radians. Make sure you copy this down. This is important. In other words, the distance around the circle in degrees is 360 degrees. The distance around the circle in radians is 2 pi radians. Remember, in other words, 2 times 3.14 or 6.28, but we're just going to leave it as pi, okay? So we're just going to say 2 pi instead of 6.28. Because remember, 2 times 3.14, that's pi right there, is 6.28. We're just going to say 2 pi, okay? Now, notice here, if I were to take half of this, right, half of a circle is 180, half of 2 is 1, right? So here we go. We can also say that halfway around the circle is 180 degrees or pi radians. In other words, 180 degrees is equal to pi radians. So all that happened here was I took half of this, got 180. I took half of this, which half of 2 is 1. I don't need to write the 1 though, okay? And then I get this other formula here. 180 degrees equals pi radians. Okay, so now we're going to use this here to do our math today. Okay, watch this. Okay, so if 180 degrees equals pi radians, I can do two things. Watch this. Okay, I can go ahead and divide both sides by 180. Okay, and watch this. 180 over 180, that becomes a whole fraction. So I get 1 equals pi radians over 180 degrees. Okay? So in other words, 1, because I divided by 180 on both sides, is equal to pi radians over 180. So we're going to use this to help us convert some degrees to radians and radians to degrees in a moment. Okay? Now let me write the equation all over again. I'll just abbreviate radians. And now this time I'm going to divide by pi radians on both sides. So now this cancels out, and I end up with 1 on this side, and this time I have it upside down, right? 180 degrees over pi radians. So both of these are equivalent equations. Okay, in other words, we're saying the same thing, but in a different way. 1 is equal to pi radians over 180. And over here, we could also say 1 is equal to 180 over pi radians, okay? Now, watch this. I'll make it easy for you guys. When you're converting from degrees to radians, you always want to end up with radians. So we're going to multiply all these, okay? This is times, not a decimal here. Okay, and you're going to need a calculator, so make sure you have it handy, okay? Now, remember our two little equations here? Those right there? Okay, it came from the 180 equals pi, remember? And so, notice here, if we're converting from degrees to radians, we always want to end up with pi in our answer. Okay, notice how none of these have pi, the pi symbol, so that means we're going to have to end up with pi in our answer. So what do? We got to use this equation right here. Okay, so this is to convert to radians. Okay, so if you want to convert to radians, you got to remember to multiply by pi over 180 for all of these. Okay, again, I want to go from degrees, which is what I'm starting with, and I want to end up with radians. So that's why I want to end up with the pi. So pi has to be in all my answers when I end up in radians. Okay, so watch this. I'm going to use my calculator and check this out. It's basically, I'm going to multiply across. Okay, I'm not going to cross multiply. I'm going to multiply across. 45 times pi is 45 pi. And then over 180. Okay, we'll go back and reduce this in a moment. But look, all these are going to be the same. 165 pi over 180. Okay, in other words, I'm just making these into fractions and I'm just multiplying across. Okay, so 720 pi over 180. Again, 195 pi over 180. Notice how they all have pi over 180, right? Okay, now the next part is just reducing the fraction. And my calculator has a feature where I can write it into a fraction. So 45 over 180, and it'll reduce it for me. Look at that, 1 over 4. So really, if it's just 1, it's just going to be 1 pi or just pi over 4. That's it. Okay, let's do this one. 165 over 180. 165 over 180. And I get 11/12. So this will be 11 pi over 12. See how easy that is? Let's do 720 over 180. So 720 over 180. I get 4. So this is just 4 pi. No fraction there. It's just 4 and pi. Okay? And finally, 195 over 180. 195 over 180. And I get a mixed number here. So what I'm going to do is I'm just going to hit shift. And that's going to change it into an improper fraction for me. So 13 pi over 12. Okay? And that's all there is to it. Notice how all these have the pi symbol in the answer. Why? Because I'm in radians now. So radians will always have the pi. Okay? All right. Now, last one. What if we're going in the other direction? Converting from radians to degrees. Now, notice here all these will have pi in the problem because we're going from radians to degrees now. Now this actually is easier than the other one we just did because notice here, remember, 180 degrees is equal to pi. So all I have to do here is change that pi and substitute it into 180. So check this out, this will be 2 times 180 over 3. 5 times 180 over 2. And 9 times 180 over 4. Okay? And I'm going to use my calculator to help me do this. Okay, so I'm going to do this here. I'm going to do 2 times 180 is 360 divided by 3 is 120. Okay, so 2 pi over 3 radians is the same as 120 degrees. Okay, let's go over here. 5 times 180, I get 900 over 2, so just divide by 2. And I get 450 degrees. Okay, so 5 pi over 2 is the same as 450 degrees. And lastly, 9 times 180, I get 1620 divided by 4 is 405. So 405 degrees, and I'm done. That's all there is to it.